Okay, good afternoon, students. So, in the last class, we discussed about the latent heat of heat, right? That is change of heat, correct? So, we shall have a recap of last class for a few minutes. Then we will proceed with the next topics. Okay. So, coming to this latent heat, what do you mean by this latent heat? Latent heat is nothing but the amount of heat required to change the state of a substance at constant temperature. Okay, is known as latent heat. As you know that when you are changing the state of a substance from, for an example, from solid to liquid, or it can be liquid to vapor. Okay, so what happens? So the temperature doesn't changes until the entire substance get converted into another state. Okay, once the entire substance gets converted into another state, then there will be a increase in temperature. Okay, so hence while change of state taking place, the temperature of a substance remains the same. Okay, so that is regarding the latent heat. Okay, amount required to change the state of a substance at constant temperature. In that latent heat, you have two types. One is latent heat of fusion or melting, we call, and another one was latent heat of vaporization. So coming to this latent heat of fusion or melting, it is said that the amount of heat required to convert unit mass of a substance from its solid state into its liquid state at its melting point. It is known as latent heat of fusion or melting of the substance. Okay, so it is used to convert the amount of heat required to convert the unit mass of a substance from its solids to liquid state at its melting point. Okay, that is from ice to liquid. So mathematically you are going to write that one as Q is equal to M L subscript F. So Q denotes the amount of heat supplied, M is the mass of the substance, and LF is the latent heat of fusion. So next, the SI unit of latent heat is, it is joule per kg. Okay, the SI unit of latent heat is joule per kg. In the CGS unit, you are going to call that one as calorie per gram. Okay, so next, coming to this latent heat of vaporization. So coming to this latent heat of vaporization, it is nothing but the amount of heat required to convert unit mass of a substance from its liquid state to its gaseous state at its boiling point. The amount of heat required to convert unit mass of a substance from liquid state to its gaseous state at its boiling point is known as heat of vaporization. Mathematically, you are going to write that one as Q is equal to M into L subscript F. Okay, and we just also went through about this graph, that is plotting the graph versus, temperature versus the amount of heat supplied. So as you can see, initially the ice temperature was minus 10 degrees Celsius. If you keep on supplying the heat, what happens? The temperature of the ice decreases. Okay, from minus 10 degrees Celsius to it comes to 0 degrees Celsius. Then it starts to getting converted into another state. Okay, so there you can see the amount of heat required to convert an ice to water is nothing but it requires 80 calorie of heat. Okay, so next, once it gets converted into water, so water, when you supply the heat, the temperature of the water increases. So once the when it reaches the boiling point of water is reached, so what happens? So that water gets converted into gaseous state, right? So the amount of heat required to convert water to gaseous state is 540 calorie. Okay, so this is regarding the plot, that is temperature versus heat supplied. Okay, so next, coming to this regulation. So regulation is nothing but what? It is nothing but a refreezing, right? So we took a ice block which is placed on a wooden block. Okay, so we just took a copper wire which is placed on the ice block, and both the free ends of the copper wire is suspended by a weights. Okay, some mass attached to it. So what happens? Due to that, the pressure will be exerted on the ice. So due to that increase in pressure, what happens? The melting point of ice decreases. Due to that, what happens? The ice get melt and it gets converted into water. Okay, since that converted water is under the normal pressure, again what happens is it gets converted into ice itself. So by this way, due to increase in pressure, the melting point of ice increases, it gets converted into water. Again, that water which is converted under the normal pressure, again it gets converted into ice itself, okay, that is into solid state. So by this, the copper wire passes through the ice block without cutting the ice into two pieces, okay. So since the refreezing takes places, so this is known as refreezing or regulation we call. Hence the point which is to be noted is nothing but melting point of ice decreases with increase in pressure, okay. I think till in the last class we went through till this topic, I think, right? So coming to this triple point, okay. The next is effect of pressure on the boiling point, which is not important, okay, don't worry about that. Even the point which they have given here till here, okay, it is an extra information, okay. In case if you want, you can just go through by yourself, okay. It is not there in the syllabus, it's a extra information which is given, okay. So only one thing I need to say in that paragraph, what do you mean by this triple point, okay. So if I ask what do you mean by this triple point, I think some of you people are aware of this triple point, right? So anyone, what do you mean by this triple point? Yes, anyone, what do you mean by this triple point? Tej is the joining of electrons, okay, it's not a correct answer. Next, anyone who can give a try, what do you mean by this triple point? Okay, fine, see you. See, triple point is nothing but, I'll just read out that, let me explain later, okay. The three phase equilibrium lines intersect at the triple point. At this point, the three phases can coexist in equilibrium. That means that here a substance, okay, at the substance can exist in all the three phases, okay, at a point called as triple point we call, okay. So a substance can exist in all the three phases, okay, that is solid, liquid and gaseous state, okay. That point is called as triple point we call, okay. So in exam they are going to ask what is triple point. You need to say that triple point is a point at which the three phases can coexist in equilibrium. A substance can exist in three phases, okay, in equilibrium, you need to say, okay. That is for 1 marks they are going to ask. Let us don't go beyond in depth, okay. So 1 mark it is more than enough. Next, coming to this modes of transfer of heat, okay. As you know that you have three modes of heat transfer, right? So let us go through the explanation of that paragraph there. Heat is said to be transferred when there is a flow of heat from a region of higher temperature to the lower temperature. There are three methods of heat transfer. There are three methods of heat transmission. One is conduction, convection and radiation. Heat is transferred by conduction in solids, convection in liquids and by gaseous radiation, okay, by one object to another object without the necessity of the medium, okay. So here as we know that there are three types of modes of heat transfer. One is conduction, which usually occurs in solid, and the next one is nothing but it is convection, which occurs in liquid, and the last one is nothing but radiation, okay, that is in terms of gaseous, okay. So there you can see there heat always flows from higher body temperature to a lower body temperature, right? So let's come to this conduction of heat, okay. What do you mean by this conduction of heat? The conduction of heat is nothing but heat is said to be transferred by conduction without the actual movement of the particles from one point to another point. Okay, so in the case of conduction, what happens? There is no actual movement of particles, okay, which is present inside the substance, inside a solid. Okay, so what happens? Only it vibrates. Okay, it only vibrates, the particle vibrates, so that it passes the heat to the next. Okay, so without actual movement of particles, the heat gets transferred from one point to another point. It gets transferred from one point to another point is known as conduction of heat. Okay, so next, it is regarding the steady state. Okay, what do you mean by steady state? Anyone? What do you mean by this steady state? Yes, anyone? What do you mean by steady state? What is that Vismay Gowda which is still? Yes, Noor Fatima, give us one example regarding triple point. Okay, fine. At the last, I'm going to give that. Okay. Next, Ullas, moving in one direction. Gahana, flow process. Okay, fine. Let us see what do you mean by this steady state. Okay, so see here, for this studying this steady state, we have an experiment, okay, to conduct, so that by that experiment you can easily understand what do you mean by this steady state. Okay, so let me explain this theory part first. I'll just read out the theory part. Next, I'll explain the about that figure, how it works. Okay, consider a metal rod of length about 1 meter as shown in figure. As one end of the rod is kept in a steam bath and the rest of the rod exposes to air, a number of small cavities are made at equal distance along the length of the rod. Thermometers are inserted in the cavities. With this experimental setup, following observation can be made. First observation, what they are going to do is, let me explain the figures. Here you have a rod. Okay, we have taken a two rod. One end of the rod is denoted by A and the another end is B. Okay, and the end A is subjected to a steam bath. Okay, it is subjected to a steam bath, and the rest of the rod, the remaining length of the rod, is exposed to air. Okay, and you have a small cavities, so that where which is of in equal length. Okay, there are four cavities you can see there. Okay, in that cavities we have inserted the thermometer, which is at equidistance. Okay, this is the experimental setup. Let us see what is the observation you are going to see. Okay, you can see there the end A is subjected to steam bath. Okay, that means that you are heating one end of this rod. Okay, that is end rod end sorry, the end A of the rod is been heating. Okay, next let us see what is the observation you are going to do. So coming to this observation, the first observation they are going to say is, before heating the end A of the rod, all the thermometer shows the same reading, that is equal to room temperature. Exactly. So before heating, what happens? Okay, before subjecting this end A of the rod to steam bath, what happens? All the temperature which is placed in the cavities of a rod reads the same temperature. Okay, reads the same reading, so which is equal to the room temperature. Okay, so next point, when heating of the NDA of the rod is started, the readings in the thermometer start rising. This indicates the transfer of heat. For some time, temperature of various portion of the rod keeps increasing, and this state is called variable state of heat conduction. Okay, as you know that once you subject that NDA to the steam bath, what happens? The heat starts to flow. Okay, so due to that, what happens? You can see the increase in temperature of the rod, I mean in the increase in temperature of the thermometers. Okay, so what happens is, you can see the when you compare all the four temperatures, okay, you can see the this summit, I'll just show the figure, it will be more easy to understand. You can see here, you are heating the NDA, right? So the heat starts to flow towards the right. So as you can see there, the thermometer 1 has more reading compared to 2, 3, 4, right? So as you go away, okay, as you go away from the NDA, you can see there the decrease in the temperature of the thermometers. So the last thermometer has the very low temperature, and the first thermometer, it shows very high temperature. Okay, so this state is called as where the temperature keeps on increasing. Okay, the temperature keeps on increasing, you call that one as the variable state. Okay, it keeps on increasing. Next, after some time, thermometers do not show any further rise in temperature, but readings of thermometer are different. In fact, temperature shown by thermometers decrease as we move from hot end to the cold end. This state of the bar, when the temperature has become constant at every section of the bar, is called steady state. Okay, see here, let me explain this variable state once again, because once you come about this variable state, it will be easy to you to understand this steady state. Okay, see, variable state is nothing but, as the you are heating the NDA of the rod, so what happens? The heat transfers. Okay, so due to that heat transfer, what happens? In the thermometer, you can see the increase in temperature. Okay, it keeps on varying. Okay, initially it keeps on varying. So what happens? That state is called as variable state, we call. Okay, where the temperature shown by the thermometer keeps on varying. Okay, after some time, what happens is, all the temperature, okay, you can see when you see the thermometers, okay, there is no increase in temperature. Okay, so you can see there in the figure, the temperature 1 has more temperature, and sorry, the thermometer 1 has more temperature compared to 2, 3, 4. Okay, similarly, the last thermometer has the least temperature, and thermometer 1 has the more temperature, it is showing more temperature. Okay, so that means that even though if you supply continuous heat, okay, to the rod, so what happens? There is no increase in temperature in the thermometer. Okay, so that state is called as steady state, where no increase in temperature takes place in the thermometer. We call that one as a steady state. Okay, so this is the difference between this variable state and the steady state. So that is why they have given that the steady state of the bar, when the temperature has become constant at every section of the bar, is called steady state, whereas the temperature becomes constant, so that there is no increase in the temperature. Okay, so no increase in temperature in the thermometer. Okay, so that is called as steady state. Okay, is it fine about this experiment? And is it fine about that variable state and steady state? You do one thing, just go through once. In case if you have any doubts, please let me know. Yes, any doubts? So any doubts, please do ask. Yes, Ashrit, tell about one's steady state. Ullas, can you explain the diagram, sir? Okay, Rakesh, not understanding. Okay, fine, see you. See, first of all, you have a figure. Okay, so see here, you have a rod. The end, the two ends of the rod has been denoted by A and B. Okay, the end A of the rod is subjected to steam bath. Okay, that is nothing but you are supplying the heat to the end A of the rod. So in that rod, okay, you have four cavities, where in that cavities you have placed the thermometer. Okay, initially at room temperature, what happens, I mean initially before heating the end A of the rod, okay, so what happens is the thermometer shows the temperature which is equal to the room temperature. Okay, so all the thermometer reads the same reading. Okay, so that is the first point. Second, let us say that you are supplying the heat to the end A of the rod. So what happens, okay, when you supply the heat transfers from end A to end B, right? Okay, so due to that, what happens, there is a increase in temperature of the thermometer. Okay, so the temperature, as you keep on supplying the heat to the end A, what happens, the reading which is shown by the temperature keeps on varying. Okay, it keeps on increasing. That state we call that one as the variable state, because the temperature shown by the thermometer is increasing, that is varying. Okay, that is called as variable state. Okay, so next is the thing where after some time, okay, after some instant of time, even though if you are supplying the heat to the end A, what happens, the thermometer doesn't show the increase in temperature. Okay, so when you just go through all the four thermometers, okay, so what happens, all the thermometers doesn't show increase in temperature. Okay, that means we say that the temperature, the thermometer, okay, all the thermometer, when you compare that all the thermometer, there is no increase in the temperature. Okay, that is the thing there. Why is that? Because the temperature, you can see there, as you keep on increasing the heat to the NDA, what happens is the temperature becomes constant. Okay, the temperature becomes constant at every section of the rod. So even though if you increase the temperature, the thermometer doesn't show the increase in temperature. Okay, so that is called as steady state, where the temperature, where the thermometer doesn't show the increase in temperature, that is called as the steady state. Okay, this is regarding the difference between this variable state and the steady state. Okay, hence the steady state is nothing but when the temperature has become a constant at every section of the bar, so that there is no increase in temperature shown by the thermometer. Okay, so that is called as the steady state. Is it fine? Is it fine, Ullas, Ashrit, Rakesh? Okay, fine. So coming to the next one, see here, it is temperature gradient. Okay, temperature gradient. Let us see what do you mean by this temperature gradient. It is said that if T1, T2 represents temperature of hot end and cold end respectively, and L the length of the rod, then the quantity T1 divided by T2 divided by L, which represents the rate of change of temperature with the distance along the rod, is called temperature gradient. If dt is the fall in temperature across a section of width dx, then the temperature gradient can be written as dt by dx. Okay, see here, as you know that we have taken a rod here. Okay, so let us say that the one end of the rod is at higher temperature and the another end of the rod is at lower temperature. The hot phase of the rod is denoted by T1 and the cold phase of the rod is denoted by T2. As you know that, for example, when you take a rod, okay, when you start heating one end of the rod, okay, so what happens as you go away from the rod, okay, you are heating, you are supplying the heat to one end of the rod, whereas when you go to the another end of the rod, okay, so the temperature at another end of the rod will be less compared to the first end of the rod, right? Correct. That is what they have given here. So as you go away from the rod, so what happens, the temperature keeps on decreasing. See here, let me see, explain it. This is the end A and this is the end B. So you are heating, okay, you are heating this end A of the rod. So what happens, as you go away from the end A of the rod, the temperature keeps on decreasing, right? When you measure the temperature at this point B, that is end A, and the end B, obviously at the end A the temperature will be more compared to this end B, right? That is what they have given. So as you go away from the rod, so what happens, the temperature decreases, okay. This fall in temperature is denoted by the term dt, okay, and a width of cross section, area of cross section of width is nothing but dx we have taken. So hence that dt by dx is nothing but, we call that one as temperature gradient. That is nothing but rate of change of temperature with the distance along the rod. So as the distance increases, okay, what happens, the temperature falls, there is a fall in temperature. That itself we call that one as the temperature gradient, okay. So next, coming to this thermal conductivity, okay, to just go through about this thermal conductivity here, this is an important topic. So the numerical, I have said already, from this chapter there will be one numerical, okay, which is a very important numerical, okay. So that will be based upon this thermal conductivity topic itself, and even in your CET or NEET, okay, there will be a compulsory question from this topic, thermal conductivity, okay. So let me explain here, just I'll read out. Consider a conducting slab of uniform cross section A. Let one face be at a temperature T1 and the opposite face is at temperature T2, where T1 is greater than T2. Experimentally, it is found that the amount of heat flows from hotter phase to colder phase is, okay, see here, we have taken a conducting slab, okay. You can take a conducting slab or you can consider a cube. In some of the textbook they have considered the cube, okay, one and the same, okay. You can either consider the slab or you can take a conducting slab, okay. So one end of the slab is denoted by the temperature T1, okay, and the another end of the slab is taken as temperature T2. So in the bracket they have given that T1 is greater than T2. That means that the one end of the slab is greater in temperature compared to the another end, okay. So let us say that the first end of the slab is at higher temperature and the second end of the slab is at lower temperature. So this is the experimental setup. Next, what experimental observation we are going to see is, the heat supplied is directly proportional to the area of cross section, okay. Whatever the heat you are going to supply, that will be directly proportional to the area of cross section of the slab, okay. Hence it is said that Q is directly proportional to A. I think that proportionality term is missing there, okay. So hence Q is directly proportional to A, okay. And the second point is nothing but, it is said that directly proportional to the temperature difference T1 minus T2 between two phases, okay. It is said that the whatever the heat you are going to supply, it is directly proportional to the temperature difference between the T1 and T2, okay. That is the two faces of the conducting slab. Next, it is said that directly proportional to the time T for which the heat flows, okay. That means that Q is directly proportional to T. That means that if you are supplying the heat for more time, okay, so what happens, the temperature of the conducting slab increases. If you supply for a small time, the temperature of this slab will be less, right? Hence it is a directly proportional. Q is directly proportional, okay. So sorry, there is the term is missing there, okay. It should be proportional there, and even this should be a proportional one, okay. So all these 3 points, that is Q is directly proportional to area of cross section, Q is directly proportional to the temperature difference between the two faces of the conducting slab, and directly proportional to the time. Okay. So next let us see the whatever the amount of heat you are supplying will be inversely proportional to the distance. Okay, inversely proportional to distance. Why is that? As you supply the heat, so what happens, as you move away from the, as the distance increases, what happens, the temperature decreases. That is why it is inversely proportional. Okay, so Q is inversely proportional to 1 by L. So clubbing this all the 4 points you can write, that is Q is proportional to A into T1 minus T2. Okay, T1 minus T2 into small t divided by L. Okay, so Q is proportional to A into T1 minus T2 into T divided by L. Okay, so then since this is a proportionality term, just replace that one with a constant term, that is nothing but you can write that one as Q is equal to Ka into T1 minus T2 into T divided by L. Okay, so this is the mathematical form of thermal conductivity. Okay, so where K is called as the thermal conductivity, or we call that one as coefficient of thermal conductivity of the material of the slab. Okay, so since if you consider, if A is equal to 1 meter square, that is the area of cross section, right? If it is equal to 1 meter square, then the length of the rod is equal to 1 meter. If the temperature difference between the first phase of the rod and the second phase of the rod is nothing but equal to 1 Kelvin, and the time is equal to 1 second, then this equation is nothing but equal to K is equal to Q. The equation get reduces to K is equal to Q. Okay, so this is regarding the thermal conductivity. Do one thing, just go through about the temperature gradient, then next go through about this thermal conductivity, just go through the all the points and the mathematical equation. So in case if you have any doubts, please let me know. Just go through once. Yes, Rohan, who said to write the notes, man? I'm saying from the beginning, no need of writing the notes. Okay, the PDF notes which I have sent, that itself is a notes. Okay, so just write on the questions which I say, make a practice of that. Okay, that is more enough. Tasneem Khanum, sir, is this chapter including NEET syllabus? Yeah. Okay, fine. uh, Now it's time for assignment. Okay, so coming to this assignment part, just write the definition of triple point. Okay, define triple point. Next, it is regarding yes, it is regarding thermal conductivity. Okay, just practice about this thermal conductivity. Okay, that all the 4 points which I have written, directly proportional to A, directly proportional to T1 minus T2, directly proportional to T, inversely proportional to L. So all clubbing those all the 4 points, the equation what you got is nothing but this one, right? Q is equal to Ka into T1 minus T2 into T divided by L. Okay, so that is called as the equation of thermal conductivity. Okay, so till here this topic, just write down the assignment of this topic, thermal conductivity. Okay, and in addition to that, definition of triple point. That is enough. Okay. Okay, fine. With this, we will conclude today's class. Gahana College open agutta. The management is going to decide that. Okay, you are going to get the official message from the college regarding the opening of college. Okay, so don't worry, they are going to inform when they are going to open the college. Okay, with this thing I'm just ending today's class. Okay, thank you students, thank you. Rajesh, temperature gradient, if you want you can write, man. Okay, okay, fine, we will end the meeting today. Okay.